next speaker is Associate Professor Brent Richards from Griffith University at the Gold Coast Hospital and Health Service, and he will be speaking to us on artificial intelligence and ethics. Dr. Richards.
Thank you for inviting me, and hopefully that screen's showing this is a technology talk, so almost invariably the technology fails.
It's working.
Beautiful. Okay. Thanks for inviting me, and it's great to see people interested in the world of AI, because I actually think that this is going to really radically affect all of our lives in the very near future, if not already today. Artificial intelligence is being touted as the fourth industrial revolution, and it's the biggest and fastest moving industrial revolution we've seen. Whereas it used to take years to take a tractor and produce a factory and get it out to the field, we can literally spin up an algorithm overnight and have it on 1,000 phones in the morning. So it's moving really quickly. And that's an interesting combination of the fact we've got huge amounts of data now coming to us, great computing power, tools which are increasingly available and in general are free, and the ability to develop neural networks. So putting all of that together, we've got a revolution that is moving at a great rate of knots and is actually coming to us very quickly. Ginni Rometty, who's now the executive chairman of IBM, previously the CEO, at the World Economic Forum a couple of years ago said that AI will change 100% of jobs. And this hasn't been disputed. And I do believe that's right. And it's worth sitting back for a minute and actually reflecting on that your friends, your family, all of your colleagues, their jobs are going to change. Now, it's not their entire job that's changed, it's tasks that change. But that's the level of change that we're going to see. So therefore, the change is going to be continuous. So people are going to have to get comfortable with the fact that things are changing very quickly. In the world of healthcare, I'm starting to see artificial intelligence as a third major A of disruption in healthcare. So there was anesthesia, there was antibiotics, and AI. And I believe that the level of disruption we're going to see is at the level we saw from anesthesia and antibiotics. And it's worth considering that just in terms of scope. Frankly, as a clinician, this could not come quickly enough. And we've got two major problems sitting in front of us. The first is that we tend to sit normally in that combination between a cognitive and a process space, but the amount of data that's coming at us is actually starting to drown us. So we're actually drowning in patient data, which is just pushing us more and more into process and further out of the cognitive space. And we are now starting to make a number of errors based around having too much data and not being able to process all the data. So what we actually need is to move into the AI world so that the AI-enabled data analysis and decision support that goes with it can actually deal with a lot of that rapidly rising wave of patient data and allow us to get back to providing empathic value-based care, which is what clinicians are remarkably good at and frankly, where we want to be operating. There is also a second major issue, and that's cost. At the moment, 30% of all government budgets are actually spent on health and aged care. Current predictions are that this will move to 50% by 2050. Now, that's a big number. What that means is either we've got to markedly increase taxes to pay for it, or we've got to have no schools or roads, or we need to move to some radical changes in healthcare. And the only radical change that I can really see on the horizon is AI-enabled healthcare. So it couldn't come fast enough. The good side is that we are at a point where we're collecting data. And the data is worth an enormous amount. And this is from the NHS, and this is over a year ago, where they actually said that the curated NHS data sets were worth about £5 billion per annum and patient benefits of similar levels. Now, these are big numbers, but I actually believe this is a reality, is that this is an asset we're literally sitting on. And haven't been using the way that we could. And it's the techniques and technology around artificial intelligence will get us there. And data, in many ways, is the gift that keeps on giving. Is that it's a renewable resource that actually keeps getting better. You can extract more and more value out of the data as you keep reusing it and keep refining it. What's critical in that discussion, however, is that a single piece of data is not that useful, and you've got to keep aggregating. So the current data, you actually end up with some good initial views of it, but then you've actually got to use more data and more techniques and start to get to a point where you can work across multiple data sets. And then you've actually got to get into the streaming analytics pathway. And for this to get out into the world of the clinician and the bedside, this has got to happen in real time. Now, technologically, this is completely feasible, but this is the way that we need to approach this. And I think this is just something that, excuse me, is happening overseas. It's not. So there's an AI action plan out for discussion at the moment. In fact, they're still open for comments through to like the end of next week, where they're actually looking at how AI can impact positively on all Australians. And so they are very clearly, the federal government is clearly looking for feedback in the space because it's coming very quickly. And they realize that we actually need to jump on this train and move with it, because this is what's going to help us move our society and particularly healthcare forward. So the question, what is AI? And there's a lot of potential ways of actually looking at it, but normally it's talked about as the use of a computer-based algorithm to perform tasks that would require intelligence if performed by a human. Now, intelligence is a variable term, and it's very hard to actually define intelligence in its own right. But it's usually splits out into areas: predictive analytics, which is classic medicine, as I want to predict something; voice recognition, natural language processing; image recognition, and robotics. And in the area of language processing, that's moved ahead really quickly. So it's both the spoken and the written word. And then you'll hear that there are different learning techniques. Supervised learning, which is what we're used to, where we're actually trying to predict an outcome. Unsupervised learning is where we're looking for patterns. And something you won't hear much about yet, but will be growing rapidly, which is reinforcement learning, which is what won the AlphaGo competition, or the Go competition, where the Go master was beaten, where the rules keep changing as the scenario change. And if you think about medicine, that's exactly what happens. A patient is not a static entity. A patient's physiology keeps changing. And so therefore the algorithms need to change along with them. AI is not new though. It's actually been around since the 1950s. And it went really well for about 20 years. And then when they realized they didn't have the computational space, they actually had to pull back, and it went through an AI winter. And then it came back out of that when Kasparov beat Deep Blue in the mid-90s. And it's really come of age since about 2012 with neural networks. So is it there and are we using it? Well, absolutely. In the past, we would use it to recognize patterns and handwrite these steps, because what happens is a computer program now does that for us. It actually finds the patterns. And if you think this is something that everyone else is doing, you've used it, and you've probably used it today. If you've got a Google Home or an Alexa or even Siri on your phone, you've used AI. If you drove to work and used Google Maps, you've used AI. If you used your credit card, the fraud detection was actually using AI. And tonight, when you're actually watching Netflix, it's the AI that's giving you the recommendations. And the simplest way to think about AI is that it's really nothing special. We used to take historic data and look at the historic outcomes and then define the rules to get from one to the other. And so we would do that by human experts defining the rules. Because what you do with AI is you simply get the computer to actually work out those rules for you. And it can obviously look through many more possibilities than what you would see otherwise. And from there, you get the new data and you move to outcome prediction. And a simple way to look at it is one of the classics in AI, which is the driverless car journey. In the driverless car journey, we have a whole bunch of sensors we have attached to a car. We have an action where we actually need to get from point A to point B in the quickest, safest way possible. And then the outcome is that we arrive at our journey safely and quickly. And if you think about that in terms of the patient journey, it's really very much the same. We have a whole bunch of biosignals, both electronic and physiological, and we have an intervention. We want to get someone from the front door of the hospital through their elective surgery and back out to the home as quickly and as safely as possible. Because what that means is all the technology and all the techniques we're talking about for the self-driving car, we can bring to bear to healthcare, and we can really improve our healthcare systems by working in this space. So let's have a look at some of the research that's already out there where healthcare is being impacted by artificial intelligence. So this is a paper actually from 2015. So it's actually quite old in the machine learning world. And this is where they tried to predict the onset of septic shock in critically ill patients. And it was a retrospective study. We're using a great database called MIMIC2. And they were detecting it with an AUC of 0.83, a mean of 28 hours before onset of septic shock, and 2/3 of patients before onset of sepsis-related organ dysfunction. Now, for intensivists, this is intensive care nirvana. This is preventative critical care. And this is just one engine. And you might think, well, that's only one engine, it's retrospective. So some people took a very similar engine and put it into clinical practice. And again, this is a couple of years old. But again, a simple study, about 70 in each group. One alert, and all it did was alert people that this was likely to happen, that sepsis was likely, septic shock. It saved over that period 10 lives and $750,000 in terms of bed days. So one single rule, and this is the power of what we can do. And when I put this in front of our hospital CEO, he asked me to install it immediately. Although, as you'll see later, there's a lot more needs to go into it before you would actually do that. It also, AI is working in the world of discovery. Is that, again, is what they did here was look at a whole lot of septic patients and categorize them as people would normally categorize them according to SIRS criteria and SOFA criteria. But then is what they found is they used an unsupervised learning technique called K-means cluster analysis and could divide this up into very clear groups with quite different ICU admissions and inpatient mortality, even though the SIRS and SOFA were not that different. So they could detect novel clinical phenotypes in sepsis by using artificial intelligence techniques. So it not only helps predict, but it also helps discover. And then similarly, the MIT group, which with Leo's group, did something similar where they looked at the same database and actually used reinforcement learning to look at what was the best treatment in a septic episode as the patient continued along their pathway, their journey. And again, showed that by using reinforcement learning, they could create a very good artificial intelligence algorithm, which could then advise on the right treatment at the stage of the journey the patient was on. So we'll move into images. And again, imaging is something that, or image recognition is something that AI is incredibly good at. And so anything in medicine that is an image is something that we can turn our hand to get artificial intelligence working on. And the Stanford group have been really good at this. So a few years ago, they managed to show that pneumonia could be diagnosed on a chest X-ray with a AI algorithm. But that following year, they decided they needed to do better. So they actually got 14 different diagnoses and showed that they were performing at the level of a Stanford cardiothoracic radiologist. So at a very, very high level. And this means that you're actually starting to bring specialist level care outside of a specialist environment. So this may not be important for Stanford, but it would be very important if you're out in Mount Isa, let's say. The other thing in terms of this is that the average time to read the 420 chest X-rays was 240 minutes for a radiologist, and that's a pretty good radiologist, and 1.5 minutes for the algorithm. And in this circumstance, you'd use it as a second read, not as a primary read. But in the middle of the night, when the cover of medical staff may not be what you want, I would certainly think that this is something that we would use. And within our own emergency department, they're looking at doing something exactly like this, which is to use algorithms like this as a second read. And it's already got out into the commercial space. So GE this year released a new portable X-ray machine, which has got AI embedded in it. So therefore, if a patient has a pneumothorax, they can see that pneumothorax straight away. And therefore, it alerts them on the screen. Again, it's a decision support tool. It's an alerting tool. But this is already out there and it's being sold. And another area which is getting even bigger, this is Butterfly IQ, which is an AI-assisted ultrasound device. It's $5,000. It attaches to your iPhone or to your iPad, and it's available in this country now. And it's probably already sitting in the pockets of a few hundred doctors around the country. It's AI-assisted ultrasound where the AI helps you get the right picture and even helps you interpret the picture. So it's getting left ventricular ejection fractions, it's getting bladder sizes, again, using AI. So this is actually AI in use in a clinical space, improving care and providing ultrasound services to a far wider range than what we would otherwise. So it's already out there. So I'll take you through some other examples. Again, here we have cardiologist level arrhythmia detection for using neural networks. So again, looking at a wide range of arrhythmias. And here again, the algorithm was as good as a cardiologist, in fact, slightly better, at diagnosing a wide range of arrhythmias. Critical to this is the fact that they're comparing it to actual clinical performance, not to perfection. And the reason for doing that is that that's how we need to judge this. And when you look at these studies, you actually realize that human performance is actually nowhere near as good as many of us mere humans would like to believe. And so there is a real need to make sure that we do this, and literally for us as clinicians to accept that our imperfections might be a little bit larger than what we believe, and we may need some help. But there is some other places that we can take this. So again, fully automated echocardiogram interpretation in clinical practice. So again, retrospectively, took a large number of echocardiograms from a vault and basically managed to report them at the same level as an echocardiographer. So again, for retrospective review of the data you've got, and what's important is you've actually remembered to collect the data, then you've got these tools that you can actually put in place. And to move into another area, which is diabetic retinopathy. So again, this is an image. And so as you would expect, this is wide open to artificial intelligence to provide you with some very good outcomes. And sure enough, Google have done this already and produced outcomes which are equivalent to ophthalmologists in terms of recognizing the presence and severity of diabetic retinopathy. Now, does that matter in a major tertiary hospital? Probably not, although talking to the ophthalmologists, they want it themselves. But in a place like India, where there's one ophthalmologist per 500,000 people and up to a third of diabetics go blind before anyone looks in their eyes, then the democratization that this brings to healthcare in those environments is extraordinary. And that theme of democratizing healthcare, I think, is critical to how we view what AI can do. And that's a simple retinal image, but here's another step up: optical coherence tomography. It's a non-invasive way of using light beams to actually measure the thickness of the retina. And here, this was Google from a few years ago now, working with Moorfield Hospital, arguably the #1 eye hospital in the UK, and have got 50 different diagnoses at a level which is as good as a Moorfield Hospital retinal specialist. So what this means is that you can get something at a level of a Moorfield Hospital retinal specialist working in Specsavers and Gundawindi. That's how good you can do it. So this stuff is available, and it's available now. And here we are. It's actually already been deployed in the US. So this is a trial that was done in 2018, where they were using AI-based diagnostic systems for detection of diabetic retinopathy. And again, getting extraordinarily good results. And this is now an FDA-approved AI algorithm. And there are a number of FDA-approved AI algorithms out there. And again, in the ophthalmology space, you can use it for discovery. They looked at 284,000 retinal images, and they were using it to detect age and smoking status, and strangely enough got very close to it, but they also predicted gender with 97% accuracy. And up to that point, most ophthalmologists have felt that that was actually impossible to do. So there's something that the algorithm was seeing, which the human eye was not actually detecting. And that's actually that discovery piece, that where we can learn completely new things, is, I think, a really critical part of where we're going to go in the AI space. Now, AI is not perfect. When Google actually took their diabetic retinopathy out into the real world, and I think this was in Thailand, that actually didn't work very well. And what it was is they hadn't translated their research into practice. So once they got out into the practice world, they found that particularly the internet was far too slow in many places. And also they hadn't counted on the image quality issues, and there was some huge problems with image quality because of the way that actually written the protocol, which was it was going to default, the patient would default through to a referral to a hospital, which was therefore going to, which was very good for the patient, but was therefore going to cause the patient a lot of problems in terms of costs of travel. It literally failed in that environment, and they've had to go back and rewrite their algorithms as well as rewrite their protocols to actually make this work properly in a clinical environment. But what's important is that you get the right data. And the reality is we've got an enormous amount of data. If you actually have a look in my world, which is intensive care, we have huge amounts of data, and most of it goes to waste, to be frank. Fortunately, within Queensland, we've got a clinical information system that we've had for over 10 years, and we've got minutely data sitting there. And if we pulled all of the intensive care data sets together, we'd probably have around 90,000 patients in a data set, which is what I'm working towards. Because that's a level of data and information that's going to give us some huge insights into practice and help us to move forward. But there's another part that goes with it, which is actually further valuing the data. At the moment, all the data off the monitors goes nowhere. So there's data flowing across your monitors at about 240 data points a second, 240 hertz. And it goes, in software terms, to the dev null port. It goes and it disappears. So we've actually written the software and have started to stream this into a database. And it's only going to be around about 8 terabytes of data a year, where we're collecting that full disclosure ECG and all the waveforms into a database so that we can then analyze it and study it, and then in time start to create the algorithms that can feed back to the clinicians what we're finding. You might go, well, we can't see much in the screens, what's important? And that's part of what's going on, is that once you actually start bringing computers into the realm, you can start to find stuff and see biomarkers that you wouldn't otherwise see. And so this was an initial study we did on heart rate variability. Your heart rate is naturally variable, and the sicker you are, the less variable it is. And we actually showed that in the first 24 hours, looking at heart rate variability alone, we could actually separate survivors and non-survivors on derived parameters of heart rate variability in both subarachnoid hemorrhage and traumatic brain injury. This can only be done with collecting a 240 hertz signal or above, and also doing high-end computing analysis on it. But it's not actually that difficult to do in the current technology world. So you actually have a look at that. We've got access, particularly in the intensive care world, to enormous amounts of data, which is being used well, but probably nowhere near as much as it could be. And that begs its own question. But if you have a look at the intensive care data set nationally, there's a very broad but not very deep data set with over 1.5 million patients in it. You then look internationally, you've got the EICU and the MIMIC data set, 60,000 patients in the MIMIC data set, down to 15-minutely data. If you look at the Gold Coast Neurovision Vision data set, we've got 15,000 patients, again, down to minutely data. And now we're getting down to the 240 hertz data off the patients, which we're collecting prospectively. That's an enormous amount of data that we can actually start to play with. And although in the past that would have been considered very difficult to do, in the world of cloud technology and AI and the tools that go with it, this is actually now remarkably easy to work with. And if you look in other specialties, you'll actually find that there's an enormous amount of data being made available online, and a large amount of it's de-identified. There's now over 500,000 chest x-rays available, variably annotated online. There's a place called Kaggle, which is where AI nerds like myself go, and there's competitions in terms of who can develop the best algorithm. They've got 3,800 data sets in healthcare alone. Some good, some bad, but it's a place you can actually go looking. The NIH has got lots of data sets. There's a whole lot of COVID data sets, and both data.gov.au and healthdata.gov have got many available data sets. And all of these provide considerable opportunity for people to actually explore this data further and to develop new insights. And at times you would need to ask the question as to whether we need to start moving researchers more into these spaces, particularly those that are learning their craft and learning their trade. Because at the moment, we're spending an enormous amount of research time and effort in acquiring data when there's these massive data sets available for people to actually work with and learn from and develop insights, rather than people spending a large amount of time and effort on what can often be 10 or 20 patients. The other thing that's important in this space is that there is a new skill associated with this, is that the skill is, I have the data, what is the question? Now that's very much a clinical epidemiologist's way of looking at the data, rather than traditional research. And it is a new skill to learn, but it is a skill that goes with working with big data sets and AI. But here's the big question. Will AI be trusted by clinicians and by patients? And is it as simple as this? Trust me, I'm a doctor. Here's your AI doctor. Dr. Silver's here, ready to serve you. The answer is, at the moment, you're not going to trust Dr. Silver. However, if you're in the cabin of a burning LPG tanker and all the first responders have stepped back and the only responder I can send you is Dr. Silver to come and rescue you, I can assure you, you will trust Dr. Silver. But how acceptable is it? Well, actually, the patients are ahead of us. Patients are starting to accept it. And again, this is a PwC study from a couple of years ago, which basically showed that in first world countries, 40, 45, 50% of patients were prepared to accept AI and robotics in their care. But the other critical point that's in here is that the less care that people could access, so places like Nigeria and Turkey, the more they would actually accept AI in their care. And that's critical. And this is a survey taken long before we're actually at a point where people are starting to understand what the capabilities are. And a paper from Nature, it looked at over 1,100 chronic disease patients. And again, people were prepared to accept and in fact welcome AI into their care. And as that quote shows, people are actually starting to understand that doctors are actually drowning in their data, and that they do need the AI to help them. And the sort of the 15 to 20% we're not particularly keen on it, or we're against the use of it, is actually not that much different to most other diseases and most other treatments that we actually look at. So it's actually not far from where we've been. And it's going to get more interesting because over a year ago now, Babylon, which is a big AI company in the UK, said that they'd actually just got to the point of passing the GP exam with their chatbot. Now, it's been argued, but that does show you this is the level that it's at, and that shows you where both the understanding of the language is going, and where we could potentially be. And although, again, this may not be particularly important in a first world country, although there's 45,000 UK residents signed up to the service in London, they're deploying this into third world countries where it's this or nothing. And certainly this is going to become a big part of care as care goes on. And in fact, even in those countries where they're developing good medical systems, they're still saying that they actually do need this. So will it be trusted? The answer is yes, but what's required is for it to be researched, for it to be ethical, and to be working in proven production systems, and therefore with clearly improving the clinical outcomes. So there's been a great discussion paper done by CSIRO on artificial intelligence generally, looking at Australia's ethics framework. And it covers what you would expect: regulatory and compliance, fairness, contestability, accountability. And it's a really good read if you want to go and look at it. I'd like to take it a little bit further though, which is what it would take to earn trust in healthcare AI. What is it that we need to do? And really, this is standard practice for research and HRECs. Act ethically, minimize bias, demonstrate research positive outcomes, be safe, good governance, and some extra pieces: assuring the development process, make sure that what we're doing is secure, and make the AI easy to use. Ethics, I don't need to talk to this audience about pillars of medical ethics, but in fact, in the technology world, they're going down the same path. There's actually the Hippocratic Oath for AI developers, which was put out by Microsoft, and it's got very similar principles sitting behind it in terms of safety, privacy, security, accountability. So the technology industry is looking very hard at this, that they need to make sure that they get this right. And so there's big divisions of big companies working very hard in this space. So bias is a big issue. and it's discussed enormously in the AI space. And it really is an issue. If you have a look over on the left-hand side of that slide, where you've got gender neutral terms actually being translated into gender non-neutral translations. And again, that's because the data was biased in that circumstance. Again, when you're looking at facial recognition, you find that the darker female faces got far lower accuracy. And the point that's made here, which is a little bit tongue-in-cheek, is how do you program bias into a machine without even thinking about it, is quite right. You've got to be careful here. Most of your bias is actually going to be in your data, but it's also in framing your problem to make sure you framed your problem correctly. And also in collecting your data, there can be filters built into how you collect your data and even into the machines that are biasing your data. And then in how you prepare your data, and again, it's the filters that are there. The reality is that bias is not just an AI issue. There's over 180 recognized biases that we work with. Stability bias, harmony bias, self-interested bias, recency bias, we all carry those biases. And so the reality is that our research has been covered by bias for a very long period of time. And if you look at clinical medicine, we've actually been managing bias for a long time. So clinical medicine is actually very well paced to understand and work in this bias space. And so I think that that is actually critical. Technology is actually helping us in the space as well. The big technology companies have started to come out with their own tools. Google have got the what if tool, so you can actually look at what comes out of your algorithm and see what happens if you explore it differently. And IBM have got their AI Fairness 360. Again, great technology, and it would be actually interesting to apply this retrospectively to some of the work that we've done previously prior to AI. I think we might find some interesting results. And amongst this, we certainly need to start moving to the cloud. The cloud is secure, it's private, it's logged, and it's got a very wide tool set available. And so if you're not talking about the cloud, we really need to be there. The cloud is HIPAA compliant. It's actually certified by the Australian government as being secure. Your banking records are there, the cabinet and conference documents are there. And if you actually have a look at when Petya and WannaCry hit the NHS, the NHS have got hit twice. Why? Because after 2 weeks, they hadn't actually patched most of their servers. AWS and Azure had patched all of their servers within an hour of the first attack. And that's the difference between working in a cloud environment and working with standalone servers. Also, you want your system to be you want to be resilient, assured, and secure. And again, business want this, business need this. If you're a bank, you absolutely need this. And so this level of resilience is actually core business for the cloud providers. And that's what's got to be critical to as we build these production systems. The other side that's in there is reproducibility. Now, we'll all go on about wanting reproducible research. Reproducible is core to working as a data scientist. And there's a great group out of Harvard who are actually pushing this really hard, is that in the world of data science, it's actually very simple. And it's what people do natively using things like Python and Jupyter Notebooks and GitHub and Docker to create environments that your research is absolutely and completely reproducible. Now, journals are starting to insist on this, and I think this is really good. And this is something we can really learn as researchers from the data science community. Cybersecurity remains a critical issue. In the cloud, it's fine getting the data to the cloud. It's not there, and it's just something worth remembering as we move into the Internet of Things and streaming data off devices, is that that's where we're actually having to look very hard for vulnerabilities. So those vulnerabilities and the ability to have what is called a man-in-the-middle attack in this space is actually still there, and something that we have to keep considering as we start moving from research to production. I don't need to tell you that clinical validation by research is what's clear, and the easiest way to work in this is to say that AI is this incredible, amazing tool and just another tool, and that's really what it is. It's just another tool. And so therefore, everything that we do in the AI space can and will just simply fit into this space. And the AI-enabled products will require both initial and ongoing research. And why? Software as a medical device is actually getting quite hard. Why? Because both the data keeps changing and the algorithm keeps changing. And so as these products come out, we are going to have ongoing phase 4 style research around all of our AI-based products. because it's not something that comes out once and just stays. It will continuously change. Google changes its algorithm every couple of hours, its search algorithm. Oops, trying to change. The other thing is explainability. All these algorithms need to be explained and explainable, so that when a recommendation comes out of an AI system, that the users can assess the biological rationale, the trust in the data points, the interventions. Again, the tools are being rapidly developed in the technology space for this to work. And the next area is user interface. This has not been looked at anywhere near as well as we would like. And there's a lot more work that we need to do in this, which is the tension between safety and SAME and user preferences, and how we communicate the probabilities and the accuracy. So this actually hasn't been well worked out in the clinical space, and there's a lot more work to do here. But again, using the technology of interactive dashboards, and I'll call it almost a self-service, is what's going to become important in the space. So translation has actually barely started. And this is a place, if you want to work in the AI space particularly, and you don't want to get too technical, this translation space is actually going to become critical. And I'll just get to the last few slides because they're important. Privacy is inherent to trust. Privacy is inherent to clinicians, but it's not inherent to a lot of technology companies. So it's important that when you work in the technology space, is that you don't assume that they understand what's actually ingrained in all clinicians. That the privacy is critical. And so what we actually need is legislation to protect against actions from re-identification. We also need to think carefully about de-identification because it does involve data loss. You know, this example here from sepsis, which is that if we took data out, we wouldn't actually see that halving of sepsis mortality across a period of 12 years. So it's important that the de-identification is done carefully. And we understand that de-identification is a spectrum, and that we understand the concept of reasonable de-identification so that the de-identification is appropriate for where we're actually releasing the data. The legislation you will all know very well, but I'd like you, particularly those of you in Queensland, to bring you to understand there's a thing called the Hospital and Health Boards Act, which allows people to become designated persons to access identified data for the sake of processing. That becomes really important in the research space because for me to access data, at times I need help from a technologist. So those technologists are covered by this act to be able to help me to actually access identified data and de-identify it to take it to the point of research. The data governance process, frankly, requires an enormous amount of work. We recently put it through both a research and a non-research process, and after 15 different people across these two processes, we were still pulling our hair out. The access governance is a place that requires a ridiculous amount of work as yet, and that's something that HRECs really need to understand, that researchers are really struggling in the space, and it's actually it's a major impediment to good research happening in the space. I want to leave you with a few, well, leave you with the data access pendulum as a key thought. It used to be that opening up data for access was a high risk in terms of the patient and a very low benefit it was seen in terms of the patient and in terms of overall healthcare. With where AI is going, this pendulum is changing because the bigger and bigger data sets become important. So we're moving from the why to the why not. And again, this is something we need to think about very carefully. The good point is that technology is actually going to help us. Those two celebrity faces you see in the bottom right-hand corner are actually completely synthetic. They're fake. They were created by a generative adversarial network. So again, the technology space is moving very fast. And there are both hardware and software methods coming around, which are actually helping us to produce completely synthetic or privacy preserving techniques that are actually going to make most of this privacy stuff work very well. And I'll leave you with two final ideas. Firstly, public-private partnerships. We're not going to move this space forward unless we start to actually share our knowledge as healthcare practitioners with the private sector and work in a partnership, because it's the private sector that have most of the AI knowledge. And so I think that we need to encourage that rapid development that comes with this, but we need to embrace also the challenge of sharing the data in this arrangement. So it's going to be a challenge, but both the state and federal governments are certainly strong in this area. And this is an area that we need to look at in terms of research and AI. And most of all, we need to actually look that AI is actually moving fast and is going to help us democratize healthcare. bring specialist level services to where we haven't been able to take them before. And so it's critical that we embrace this and move really fast. And I won't talk through the final slide, but AI is here. It's happening very rapidly. It's really important that we all understand what sits behind it, the research and the ethics go with it, particularly the data, and that we continue to work hard and fast in the space. My email address is there. More than happy to talk to anyone at length about this. So feel free to contact me about this once it's over. Thanks, Hudson. Over to you.
Thanks, Professor Richards. First question. Practical AI algorithm design and ethics development are disconnected in personnel and in timescale. And it's not until systems are deployed and result in unintended and unanticipated consequences that the ethical issues are revealed. Can we expect this to be the case with artificial intelligence?
I think that it's potential, but as I say, artificial intelligence is just another tool. And so it should be treated no different to us bringing a new device to market. So let's say I'm bringing a new ventilator to market with a whole bunch of new modes in it, is that you would expect those to be properly tried and tested. And that's important. But the second piece that goes with that is that the advantage that we have in the AI space is that it's built on data. And so the data is critical to keep developing the algorithm, but that also allows it to be critical for us to continue to study it. So it actually makes that last part, that phase 4 research, a lot easier than what it is in most other arenas, because they can go hand in glove. And I think that there will be a lot more attention as time goes by to make sure that that phase 4 is there and we can continue to research it as we move forward.
Thank you. And last question. Who bears the responsibility of misdiagnosis by AI? I expect the answer will be the clinician who's deploying it. So should AI tools be considered screening as opposed to diagnostic?
In the clinical sphere, we're calling them decision support. And I think that that's very important, that they are decision support, because it's the same way as us looking at any research to do with a new drug. You know, one of the first things we do in evidence-based medicine is go, does this apply to my patient? Does the research apply to my patient? And the reality is that AI is exactly the same. Is that, does this apply to my patient? You know, we realize that clinicians may give the wrong drug to the wrong patient without having read the research the same, and the same is possible in the AI space. But yes, and the reality is this is a decision support tool.
Thank you, Brent. That was just amazing, Brent. But for my HREC colleagues online, I can't help ask this, given the jibe you made about the difficulty with ethics and governance review. And I'm only going to ask, really, do you think that, based on your view of what you just said, that ethics committees are too conservative, or perhaps not well enough informed about the potential of this? And let me just give you one example. I asked some of our Queensland ethics chairs a question around a mortality index based on the use of data, and very similar, I think, to what you were suggesting. And I think the view was that it wouldn't be suitable to have this algorithm alone as the mechanism by which one could determine mortality index. But based on what you've suggested and the evidence, it would seem that one can, in fact, use it for that purpose. So,
yeah, look, one of the original authors of the Apache scoring system, a guy called Jack Zimmerman, said that outcome prediction scoring systems should be used as a drunk uses a lamppost for support, not for elimination. And that's how it should be. And I think that as long as people understand that that view from 20 years ago hasn't changed, I think it's important. And as long as people keep using the term decision support, not decision making, is fine. I think that the ability to release data for retrospective data review is important. And I think that the risks of those are not only low, but can be made extraordinarily low if you use the right tools. So the clear separation between retrospective review and then using it in a prospective way needs to be there. And we need to encourage that retrospective view. And dare I say, stop wasting a lot of people's times and money in terms of gathering data that we've already got. And so I think we need to really encourage that space. But yes, AI is frankly just another tool. And I think that it's an amazing tool. It's got incredible capability, and it is just another tool.